Okay, so the resulting picture will look like this. I make it maybe better in this one because it is in color. As you can see, the nuclear explosion starts from this stage.
Yes.
Okay, this is the start of nuclear explosion. The energy was released at this point.
Yes.
Next, it evaporated the rock. So it created the cavity of primary size, which is tend to expand by the pressure of gases.
And in the case of 150 kilotons, that's 100 meters.
100 meters is the final size of the cavity.
Sorry.
The secondary size.
Okay.
Okay, so the primary size will be a little bit smaller. And then, as you can see on the third stage, the cavity has already expanded from its primary size to its final secondary size at the expense of the neighboring area, and by compressing the neighboring areas.
Yes.
And the resulting picture will look like in this diagram number 4. So in the middle will be a cavity of secondary size, and this blue area will be called crushed zone, and the green area is damaged zone. So the filling of the crushed zone is the completely pulverized microscopic material, as we discussed.
But I'm intrigued about this crashed zone and the pulverized particles.
Yes.
Do I take it the center is still incredibly hot?
It doesn't matter,
Massive
because
temperatures.
eventually it will cool down anyways.
Right. But then we've got this pulverized dust.
Yes.
No matter what the material is, steel, human beings, granite, anything.
Anything, it will be just pulverized irrespectively of what it was. Because the pressure of these gases is so high that it will equally pulverize everything.
In your book, you explain that the pulverized dust can take the form of what it was originally.
Yes. Form and
but
the color.
then you pick it up.
Yes.
And it's just dust. It's not there.
Yes. So you can pick up some rock from here, and it will look like an original piece of rock.
Like a pebble.
Yeah, you can see the same color and the same form as it was before.
Right.
But when you grab it and you press it a little bit with your finger, it will just crush to the microscopic dust.
So the atoms of that article are still the same material.
Yes.
But they're just not they're not connected in
No, I would not say that it will be crushed to atomic structure, no. To microscopic.
No, I'm just trying to get a picture because we're going to come and look at dust later and see if it's the same dust.
Yes. Okay, so now, as you can understand this, I want to explain about the destructive factors of the underground nuclear explosion. So this is the level of surface, and this is our underground nuclear explosion. So as you can see, there was no thermal radiation, because it was underground, there was no air around. There was no air blast wave, because there was no air around. And third, the penetrating ionizing radiation that can injure people instantly could not reach the Earth's surface because as a part of primary radiation, it was absorbed by surrounding areas of the rock. So the people standing on the Earth's surface could not be injured by the radiation because it was still underground, it's contained.
When presumably Americans and Russians test an underground nuclear device, they put it underneath the desert.
Yes,
I don't know where the Russians do it, but I think the Americans do it in the Nevada desert.
Yes.
So it's underground.
In the mountain.
Sure. But is that because they're worried about material or radiation escaping through the surface and damaging people?
No. First of all, they do not want nuclear testing to create an atmospheric nuclear explosion. They just want to contain that underground. That is first of all.
Yeah.
Okay. The second thing, why they do it in remote areas, because even though this explosion is contained, the highly radioactive gases which are inside the cavity will eventually escape to the Earth's surface by some crevices in the rock.
Gases?
Yes, of course, they will escape eventually.
And they contain radioactivity?
Yes, they are radioactive. So if someone stands above the spot of underground nuclear explosion, at the time when the gases are finding their way to the Earth's surface, he will still get the radiation injury by inhaling these gases. That's why they do it in remote places only.
Understood.
But you have to understand also that the material which is in between the cavity and the Earth's surface, it serves also as a filter. So on the way, these gases will filter through it, and most of the radioactivity will remain in the rock. So when the gases reach surface, they will be somehow filtered. So as deeper you position your nuclear charge, as bigger will be the filter.
Understood.
Okay.
Understood.
So, like for example, for 150 kiloton detonated in granite, the safer distance will be 500 meters.
500 meters underground.
Yes. So when it is 500 meters underground, and the cavity will be just 100 meters, so the 400 meters can serve as a filter, quite sufficient. So when the gases reach surface, they will not be as radioactive as they...
It'd still be potentially deadly.
Yes, yes, yes. It is. You cannot stand, even if you detonate the nuclear device at 500 meters, you cannot stay in this area for probably another 2 weeks at the time of the gases escaping.
Understood.
You can still get some radiation injury.
Understood.
And you cannot go to the hypocenter for another 3 years.
3 years?
3 years, yes.
Because it's radioactive?
Deadly radioactive. And the hot.
How long does it stay hot for?
For 150 kiloton, it should be at least a year.
A year?
Yeah.
Okay.
And the radioactive probably 3 years. I mean, dangerously radioactive.
Okay.
So that's, at least I can explain why the underground nuclear explosion does not produce the destructive factors typical to Hiroshima bombs.
But you know my next question. Dimitri, you've just explained about a general underground explosion and that 150 kiloton yield explosion should be 400 meters below the ground, below the earth, 500 below the, forgive me, 500 meters below the ground, the surface. Would that be the same measure that they used in the World Trade Center?
No, of course not. What I explained to you, that was a typical safe distance for underground nuclear test, but not for the demolition. But what we saw in the World Trade Center case, it was a demolition, so it was a different arrangement.
I see.
Okay, I will try to explain it to you. The World Trade Center was positioned like this. This is the ground level. So the tower was built in that way that it went below the ground 27 meters.
Yes.
So the lowest underground floor of the Twin Tower was positioned 27 meters below the Earth's surface.
Yes.
So in order to demolish it, you have to position the nuclear charge at 50 meters below the lowest floor of the tower.
Exactly 50 meters.
Exactly 50 meters, because 150 kiloton explosion in granite, as I explained to you, produces a cavity of 100 meters. So if the radius is 50 meters, it is exactly the right position, so that the upper sphere of the cavity will never reach the Earth's surface, but it will reach the underground foundation of the tower. So the tower will supposed to lose its foundation and just sink into the cavity and melt there, because of the temperature after a nuclear explosion is extremely high.
Yes.
It's enough to melt the entire 400 meters of the tower in just 100 meters cavity. It's just like a pot and a bar of ice cream. So that was the demolition idea. That's why they position the nuclear charge, if measuring from the Earth's surface, is 77 meters.
Not
27 meters here and 50 meters here. So altogether, from here to here, is the 77 meters.
Exactly.
Exactly.
And 100 meters wouldn't work?
It would not work, because the upper end of the cavity would not reach the foundation of the tower.
I understand.
And that's, they intended it to be exactly like this.